Video we were talking about work. We had just introduced work, and at the end of the video we said that work was force times distance, or displacement rather, times the cosine of the angle between those two vectors. And if it wasn't clear, let's make it clear in this video what we mean by doing a little bit of a couple more examples. So let's say if I have let's say, for example, I'm going to have a force applied in that direction. So this is my force. And what happens if the object actually moves this way? So my displacement vector is like that. Then this angle here is the angle between the force vector and the displacement vector. And we said if they're lined up, if the force, let me undo that one. Okay, so if the force is in that direction, and so this is my force, so this is force, and let's say, for example, in yellow here, my displacement is going to be also in this direction. So there's my displacement vector. This is D. Then you can see that they're lined up. This force vector here and the displacement vector here are kind of lined up with each other, making this angle in between the two 0. So here theta would be 0. Here, there you go, a couple of examples here. I'm trying to do it freehand. Let's say here if we have the distance here and force here, now we got force that's perpendicular to the displacement, and in this case this theta here is going to be 90 degrees. Alright, what happens if I were to do this? What happens if my force is in this direction and my displacement is in this direction? Well, in this case, the angle between the force and the displacement is this angle here, theta. And in this case, theta is going to be 180 degrees. All right, so there's three cases here. Let's say this one here, for example, let's say there's 30 degrees there. Okay? So if we wanted to calculate work done by the force in each one of these cases, you'd have the work done in this case is force times distance, whatever the magnitude is of this force and the magnitude of this displacement, times the cosine of 30 degrees. In this case, the work is going to be force times distance times the cosine of 0 degrees. In this case, the work is going to be force times distance times the cosine of 90 degrees. And in this case, the work is going to be the force times the distance times the cosine of 180 degrees. So this is going to give us definitely some value, some positive value for work. This guy here is simply going to reduce to force times the displacement, because the cosine of 0 is always 1. So it's going to be like times 1, so work is simply force times distance. And that's how it always is if the two vectors, the force and the displacement, are parallel to each other and in the same direction. It's simply F times D. If they're perpendicular, if the force is perpendicular at 90 degrees to the displacement, then what happens is this cosine of 90 happens to be 0. So the work done in this case is always 0. No work is done by a force perpendicular to the movement. In this case now what happens is the work is going to be negative because the cosine of 180 degrees is negative 1. If you don't believe that, pull out your calculator in degree mode, put cos 180, and you'll see the answer is -1. So it's force times distance times -1, which is going to be negative force times distance. And in this case, we get something we didn't talk about before, but we've got something called negative work. And negative work on an object, see, we are doing, if this is us here, applying a force on an object that's going in this direction, we are actually applying negative work on the object, and the object's actually doing positive work on us. And we're going to explain that a little bit later on. But suffice it to say for now that any two vectors, one force, one displacement, you can find whether you're doing work and what that work is by looking at the angle between the two directional vectors. So because this is our complete formula for work used. Now remember last time we says work units. The unit of work was the joule. And a joule is abbreviated just with a J for joule. And 1 joule of work is the equivalent of moving something with a force of 1 Newton, 1 meter. So the textbook says if you take an apple, and remember I said an apple is about the force of 1 Newton. So if we take an apple and you raise it from about your waist to above your head, probably that's about 1 meter from your waist to the top of your head, depending. That's about 1 joule of work done by lifting an apple from waist level to a little above your head. All right, so we're going to continue in the next video with a couple of things more in this line.